Hello students, thanks for your interest shown to learn through this channel. This session we shall learn new tricks that we never know on salt hydrolysis. Okay. We know that salt is a product of neutralization. So whenever an acid reacts with a base, we get salt plus water. This we know. Fine. So we expect this salt to be neutral always, but actually it won't be. Let us take some examples. Sodium chloride in aqueous solution will be of course neutral, no doubt about it, whereas ammonium chloride in aqueous solution will be acidic, and sodium acetate in aqueous solution will remain as basic. And all these are salts. Of course, sodium chloride can be obtained by the neutralization of hydrochloric acid with sodium hydroxide, and ammonium chloride can be obtained by hydrochloric acid with ammonium hydroxide, that also we know. And when acetic acid is neutralized with sodium hydroxide, we get sodium acetate. So we are not going to discuss the detailed concept behind it. Neither we discuss the derivation that behind the formulas. All that we are going to learn is some shortcuts and basic knowledge to understand and remember these formulas. Okay. So here is the table that shows some of the strong acids and strong bases, and we need to know them. So the first three are halo acids except hydrogen fluoride, because hydrogen fluoride is a very weak acid among the halogen acids. And then we have mineral acids, sulfuric acid and nitric acid, and HClO4 is an important strong acid. When it comes to base, the first group elements, alkali metals, hydroxides are strong bases, lithium hydroxide, sodium hydroxide, potassium hydroxide. And fifth group elements, calcium, strontium, barium, those hydroxides are also strong bases. Now consider Ba is a salt. B comes from strong base. I am going to consider B comes from strong base, okay, and A comes from weak acid. Now there are two different varieties of questions that can be asked in the competitive exams. Type 1 will to predict the nature of aqueous solution. That is, you need to predict whether the salt solution is acidic or basic. For this you need to consider the strong parent's nature. Okay. So type 1 will be asked to predict the nature of aqueous solution. So nature of aqueous solution, in the sense I want you to consider the strong parent in the sense here the strong parent is strong base, okay, which means its nature will be important in the salt, aqueous solution of the salt. Okay, so the aqueous solution will have basic nature. So the trick is you need to find which is the strong parent, and its nature will be important in its aqueous solution of salt. You understand? Fine. This next one is type 2 questions. Here calculation based questions. You need to find out the hydrolysis constant KH and degree of hydrolysis, and you may be asked to predict the pH of the solution, which we are going to discuss. Will be let us study the nature of aqueous solutions of salts that are produced by different varieties of acids. If the salt is generated by the neutralization of strong acid versus strong base, then its aqueous solution will be neutral. Okay, since both the parents are strong. If the strong acid neutralizes a weak base, then it will have the strong parent's nature. Okay, here the strong parent is acid, that's why the solution, it's acidic solution, aqueous solution will have acidic nature. If a weak acid neutralizes a strong base, then the aqueous solution of its salt will have the strong parent's nature. Here the strong one is base, so the solution will be basic in nature. And if both are weak, then it depends upon the relative strength of acid or base, which is stronger, that character will be here. So we cannot say that will completely depending upon the pKa or pKb values. Okay, pKb values. So we will be discussing about this. Now the second type of questions which involves calculations. To do calculations, we need to remember formulas. So we should know the formulas for hydrolysis constant, is KH, degree of hydrolysis H, and pH of the salt solution. First, let us consider the salt formed from strong base or strong acid versus weak base. Okay. Now, the KH will be given as KH is equal to KW, ionic product of water, and KB. I want you to consider the weak parent's nature. Okay. And for hydrolysis, H will be nothing but same way KW into KB into C. C is nothing but the concentration of the solution and its square root. And pH, of course, when it comes to pH, you need to consider the strong parent. Okay, here acid is the strong parent, which means the pH must be lesser than 7. So that's why I have minus here. 7 minus half of then pKb plus log C. So this is the formula. Very simple. Let us discuss weak acid versus strong base. Now the KH will be same KW on the numerator, and we need to consider the weak ones, right? So acidic is weak, that's why Ka, and H will be square root of KW by weak ones Ka into C. Now surely when it comes to pH, since the strong parent is base, the aqueous solution of this salt will be basic in nature. That's why I have plus, right? Something greater than 7, half of pKa, it's weak acid, plus log C. Now the last one, that is weak acid versus weak base. Here for KH, it's both the numerator will contain the same KW and the denominator will contain both Ka and Kb. And even for H, I'll have KW in the numerator and denominator Ka, Kb. Very simple. When it comes to pH, I'm not sure, so that's why it is plus half into pKa minus pKb. The difference in the pKa and pKb. That's it. So let us work out some problems. The first question is, the pKa of a weak acid HA is 4.80. The pKb of a weak base BOH is 4.78. The pH of an aqueous solution of the corresponding salt Ba will be. So 4 options have been given. So here both acids and bases are weak. Here weak acid and weak base. So we need to take the last formula, third formula. pH will be 7 plus half of pKa minus pKb, right? So we know that pKa is 4.80 minus 4.78. So the difference is 0.02, right? 0.02. Half of it will be 0.01, which means the answer is 7.01.